All right, team. Wanted to record another video today. This is problem number 10 on the multiple choice. So again, they've given us a piecewise function defined as 3 times sine of x when x is less than 0, and e to the x when x is greater than or equal to 0. So the question for us that they're asking us is to find the range of this piecewise function. Well, to find the range, we want to look at the two pieces and say, what is the maximum and minimum y value for this piece and the maximum and minimum y value for this piece? Let me start with the top one, 3 sine of x. Now think to yourself, if the 3 wasn't here, right, you would say the maximum value is 1. Because the maximum value for sine is always 1. Remember, sine is a periodic function. That means it goes from side to side. The maximum value is 1. So therefore, the maximum value of 3 times 1 is, of course, 3. What is the minimum value? Well, the minimum value for sine, again, imagine the 3 is not there. The minimum value for sine is -1. -1 times 3 is -3. So it doesn't really matter for us that this 3 sine of x is only defined when x is less than 0, because sine is a periodic function. So it just keeps repeating. Doesn't really matter where it's defined. Now let's look at the e to the x. Well, e to the x, right, the graph looks like this, but we only care about it from 0 to infinity. So if we look at this piece here from 0 to infinity, we see that the maximum y value is infinity, and the minimum y value is 1. E to the 0 power equals 1. So what do you notice? When you combine these two together, you combine the 3 sine of x and e to the x, you see that the total maximum is infinity. That's the biggest y you can have, and the smallest y you can have is -3. So our range is from -3 to infinity. We got infinity because that was the biggest for e to the x. We got -3 because that was the smallest for 3 sine of x. Let me go ahead and zoom out here. Give you a panoramic shot of the entire problem. So again, we looked at the range for the first piece, the range for the second piece, and then sort of combined them together to get the max and the min. Zooming out, this is problem 10. All right, folks, I'm signing off for this problem.